Here we have the Talon RTR 2729A ultra wideband portable recording system. This recording system is extremely powerful. It has a 3.6 gigahertz A to D converter with 12 bits of dynamic range that can operate in one of two modes: a single channel mode where the maximum sample rate is 3.6 gigahertz, or a dual channel mode where the maximum sample rate of each channel is 1.8 gigahertz. Either way, it's able to capture very, very wide band signals, and it can be used in a variety of applications. What makes this system very powerful is not only does it have the high-speed A to D, but it has the ability to stream that data to disk in real time. The maximum sustained recording rate to disk is 4 gigabytes per second, and we have the ability to put up to 30 terabytes of solid-state storage in here. So that allows over 2 hours at that 4 gigabyte per second rate of data storage time. The sample clock is programmable in frequency, so the data rate can be reduced by reducing the sample rate. And additionally, we add digital down converters with programmable decimations and tuning frequencies that allow you to look throughout the RF spectrum for signals and to zoom in and further reduce the rate of data to disk. So let me show you a little bit about the system here. If I turn it over to the side here, you'll see this is where the I/O is available to the user. The high-speed A to D converter has inputs over here. The clock is generated by a clock generator card that we provide that will allow you to have programmable sample rates. In addition to that, we optionally provide a GPS receiver card. That's shown here gives you the ability to timestamp data from that's locked to a GPS satellite. It also allows you to grab position information of the system. So if this is a system that's perhaps flying in an aircraft, we can track the latitude, longitude, and altitude throughout the entire flight path while recording RF signal information. So another nice feature available in the system. There's other I/O components here available through a typical motherboard I/O facility that you would see: USB 3.0 and 2.0. In addition to that, there is gigabit Ethernet available to there. It's good for offloading data or installing programs onto the system. Let's turn this guy around. This package, by the way, is very lightweight. It's 25 pounds. It's rugged, and it meets a number of military specifications. If we look on this side here, what you see is a bay that's removable with 4 thumb screws that I've already unlatched. But when you pop this off, you'll see that there are some fans that are very powerful here that are used to pull air through the 16 solid-state drives that are here. So this allows us to cool these drives and pull the air through the system. These drives, as I mentioned, can hold up to 30 terabytes of storage. They're easily removable. Through another 6 set of thumb screws, you can pop all 16 of these drives out. In addition to that, the operating system drive resides down here, and with a single button, you can pop that guy out as well. So that allows you to very quickly take all of the data that you have out of the box, bring it back to the lab. Anything that's mission critical that needs to be removed from wherever you're at can be removed and taken out very easily. If we flip this guy around one more time, you'll see here there's a high-powered fan that's used to provide cooling to the box. And let's flip this guy all the way around. And the front of the system, you have 2 latches. You pop these guys open, and you have a built-in high-definition display, keyboard, and mouse. So everything is integrated right into the system here. You can operate it just by sitting at it. There's a built-in graphical user interface, which I'll show you. In addition to that, if you don't want to operate the system, you can leave it closed up and through the gigabit Ethernet port, hook it up to an external PC and do all the control there. So let's power this guy on and take a look at what we have. So here we have the 2729A capturing data to disk, and we're looking at the signal that's being captured. We're putting in a 505 megahertz modulated FM signal, and as you can see, we're capturing the entire spectrum from the low kilohertz range all the way up to 1.8 gigahertz. And that's the great thing about this high-speed A to D converter, is you can really look at a very, very wide band. This is just the first Nyquist zone, but obviously we can filter and look at Nyquist zones at frequencies up to 2.8 gigahertz. So you can see here the signal at 505 megahertz. You can see the time domain representation, and if we flip over and look at a spectrogram, you can see over a period of time what that signal looks like. And if we zoom on in here, you'll see there's that FM modulated signal. It's a little bit sloppy, but that's the signal up at 505 megahertz. Let's drag it down there. Also in the frequency domain, go in and zoom and take a little bit of a closer look at that signal. This is just a video zoom that we're using here. However, we have the built-in digital down converter, which will allow us to go in and have some processing gain as well when we zoom into the signal. But you can see the FM modulation moving around the 505 megahertz carrier. So again, this is the 2729A ultra wideband Talon recording system.